It's particularly important, not only when it comes to sports. Good circulation, down to the fingertips. Without blood, there's no life. And without healthy arteries guiding blood through the finest branching vessels down to the fingertips, our limbs and organs wouldn't get any energy. A team of experts from 5 Fraunhofer Institutes has initiated a process for developing artificial blood vessels in the laboratory.
Wir leben in einer sich wandelnden Gesellschaft.
We live in an evolving society. We're living longer and longer, staying fit, and of course we want to preserve our bodies. To do this, we need the assistance of medical technology, because donor tissue will not solve the problem. It's too scarce. We are working on a future technology to create artificial supporting structures that can be combined with a patient's own cells for use in transplants.
Verwendet werden können in der Zukunft.
To provide energy to artificial implants, you need a blood supply. The basis for this is this organic ink that is used to print blood vessels. And this is done on a specific inkjet printer. The organic ink is printed layer by layer to create 3-dimensional tubes that have the same properties as blood vessels. The printer works with high precision in the sub-millimeter range. But the finest blood vessels require even greater precision. Laser pulses structure the hardening polymer with a precision down to a few thousandths of a millimeter.
Wir arbeiten mit Methoden des Rapid Prototyping. Das heißt, aus digitalen...
We're working with additive manufacturing methods, meaning we use digital image information to create microscopically defined materials layer for layer. What's very special about the technology we've developed here at Fraunhofer is that it generates elastic biomaterials.
Und das ist das ganz Besondere.
The printing technology permits a range of forms and sophisticated blood vessel geometry for much better blood flow than with conventional materials. The researchers use simulations and experiments to optimize the form of their artificial vessels. Besides the form, particular attention is also given to the material used in the organic ink. The synthetic polymers must be biocompatible. They must fit the human organism.
Das Material, was nachher entstehen muss ja im Kontakt...
The material we need to create will be in contact with living basic material, ultimately with the organism itself, the body, so it must be biocompatible.
Biokompatibel sein.
Before the finished blood vessel from the printer is ready for transplantation, it has to be coated with biomolecules so that living cells can easily dock onto it. So the researchers use a bioreactor to grow a dense layer of endothelial cells on the inner walls of the vessels they have printed. This is a requirement for optimum and trouble-free blood flow in the organism. Once it is populated with cells, each tube is subjected to a thorough quality control. In a few years, one initial conceivable application for the artificial blood vessels could be bypass operations, especially since these patients often do not have any veins of their own suitable for transplantation.
Wenn wir etwas weiterdenken, kann unsere Technologie...
Thinking a little further ahead, our technology could open the door to creating entire organs. We can build the basic structure and then populate it with cells. Ultimately, the cells come from the patients themselves. Or the patient's cells will even become a part of the printing process to produce complex structures. In the end, it is realistic to think that at some time in the future, we could use this approach to build entire organs. By the time they grow up, blood vessels produced by an inkjet printer could prove very useful to these young people, for their quality of life and for their health.